Hey everyone, so my name's Matt. My professional title is a product officer. So my role is to specifically find problems that are faced by a consumer group or anybody basically, and design products and solutions and features of products that can fix those problems basically. So here's an interesting one. A lot of what's been spoken about today is investment in infrastructure or ways that getting people into community housing projects, which is amazing. But when we started, myself and my business partner, a physicist named Dharmak Mehta, he's also a data analyst at TrustPower, we looked at the housing crisis and we started to sort of think of what are the actual practical ways to fix the housing market? You know, like the question you asked, like, how does a 25-year-old buy a 200 square meter home for, whatever, 500 grand or whatever? So we started looking at this and we started to look at what are the three key drivers of the cost of housing. So one of them is the cost of land, and we know that now that there's going to be a lot more land that's going to be freed up, and it's not really something that the average person or the average builder can fix, for example. And the other two was the cost of materials. This is typically driven by some would describe it as a monopoly in the building industry, whereas if you say Fletchers, for example, they own pink bats, they own jib, they own placemakers. So a typical wall structure that is made out of jib, wood, and pink bats, 90% of those materials come from the one company. So if they want to put the prices up, prices go up. We've also seen the price of timber. I don't know if you guys have been keeping an eye on what's true inflation. 125% increase in the cost of lumber over a 12-month period. Just crazy. Steel's following, copper's following, everything's going to get more expensive. So what if I told you that 3 people can build a 4-bedroom house in less than 2 weeks? And not just 3 people, 3 of any of us. It seems odd, right? Because that's one of the biggest drivers is the human resource cost of building, right? Building is typically normally undertaken by young, fit, strong men who only are young, fit and strong for a certain amount of time. There are definitely more women joining it, but it does require a lot of physical, hard labour. A lot of those building I did 3,500 hours of a joinery apprenticeship back in the day, and actually put my hand through a table saw, which is what got me into the tech space rather than working with tools. And like what I found is like it was just an exhausting process. The reason I actually had this accident was because I was so exhausted from working 6 days a week, and I was not focusing on what I was doing. Yeah, cut my fingers off. They're here though, they're still here, so they still work. So yeah, the question is, like, how do we reduce that reliance on human capital? Like how do you produce stuff automated, basically? So I'll get to that in a second. Second thing is on a typical building site, you'll have 2 or 3 master builders, or maybe 1. You'll have a couple of apprentices who are on minimum wage, and then you also have probably some labourers as well who are also on minimum wage. So every time the minimum wage goes up, the cost of building a house goes up. Every time and these are the same people who are trying to afford to buy the houses, so they're working to buy these houses, and they're building the houses that they can't afford to buy themselves, which is crazy, for less than 70K. So what if I said that? People would think I'm crazy, right? Well, it's actually possible. We did a case study that we found that using additive manufacturing technologies, you could use a 3D printer to build a house in less than 2 weeks with less than 3 people for less than 70K, which is pretty cool. This is one example of a system that is built in the Netherlands. You can buy this cobalt system for less than the cost of an average house in Auckland. You could buy this system, which can produce this house or any house, for less than the cost of one house. Yeah, so if you bought 100 of these, you could be printing 100 houses every 2 weeks. It's pretty awesome. This is what it looks like on the inside. So then I started thinking, well, what if you swapped concrete for a waste product? What if you swapped the concrete for recycled plastic? So during lunch, if you want, around the corner, there's a 3D printer running at the moment, which is printing homewares out of recycled plastic. And then I found this company. It's a company called Seed. So this here is a robotic extruder that is printing purely waste plastic to form a small structure. So this is actually mounted What you can't see is that that's actually mounted on a robotic arm. But if I go back a couple, you could easily mount it to this particular gantry system. So this gantry system, I have a price list for this gantry system. It's only, for that sized one, you're looking at about 400,000 New Zealand dollars, which is pretty cool. So the question probably you guys are thinking of right now is like, why is no one doing this? Like, why is no one in New Zealand doing this? Well, they actually are. There's a company in Hamilton called Curox. Sorry, I don't know if I actually pronounced that correctly. And they use concrete and they use it on a robotic arm as well. So the downsides with robotic arms, for example, are that you can't build as high. So when you're looking to have higher density housing, you need to be able to go multi-story. So using a gantry system like you saw with the cold system, you can exactly do that. So what's the benefits and pros and cons? So the pros of using concrete is there's a massive cost saving. There's decreased production time, like hugely. It's going from probably 2 or 3 months to produce a house right down to 2 weeks, even less if the houses are smaller. Low human resource requirements. So people don't need to lift as much. The machine takes 1 day to set up, 1 or 2 days, depending on the size of the machine. You don't have to be hugely fit. And to operate the machine, you don't even have to be able to walk. So, some smart person in a wheelchair or someone who has a physical disability could run that rather than having some big, fit, strong young man do it. You have increased design freedoms. Typically, a curved wall in the building industry will cost 3 to 5 times as much than a straight wall. It doesn't matter with 3D printing, it's exactly the same. There's less waste, and it has a really high compression strength because it's made from concrete. The downside with concrete is it has a low tensile strength, which means it needs reinforcing. So tensile strength and compression strength are different. Compression strength is, if you could imagine a sponge, has very low compression strength. You can compress it really easy. And tensile strength is how strong something is when it's pulled apart. So in New Zealand, where the ground moves, if something goes up or outwards in an earthquake, you'll often find that concrete structures can fail sometimes, or they need to be reinforced significantly to make sure that that tensile strength is made up for. You have longer curing times because it's concrete and it's a wet material. It has a high carbon footprint because it's concrete, and high concrete usage. So you're looking at 70% more concrete in those structures than you would if you were building a typical structure out of wood or something like that. So it's a recycled plastic. You get all the same, right down to the high compression strength. It has a reasonable compression strength when compared with concrete, and it's 2 to 5 times stronger than wood or concrete in its tensile strength. It's also flexible, so if the ground moves, building flexes, doesn't break apart. You're obviously reducing plastic waste, which you can buy for less than $1 a kilo, which seems crazy, and there's billions of tons of it. We all talk about it, right? There's more plastic in the ocean. There will be more plastic in the ocean than the weight of fish by 2050, which is pretty crazy, and that's because, one, we're eating a lot of fish, and we're putting heaps of plastic back into the ocean. It has a lower carbon footprint because you're recycling waste and you're using materials that have already been created. It's significantly faster setting times. You're talking about cooling. So you have to heat the plastic. You have to heat it to about 200 degrees, which it doesn't require a lot of energy. And it sets instantly, so you don't have to wait for it to cure. It can also be transparent. So you can imagine solutions where you have a wall that gradiently changes from solid to transparent, and it'll look really, really cool. Downsides, it's susceptible to heat. So if you had an open fireplace, you would need to surround that with some traditional building material, but there are practical solutions to get around that. But, if you were to get your curling iron and stick it into the wall, you could probably do a bit of damage, but you wouldn't want to do that. It's an unproven application. No one's done this before. So there are some examples where people are using cast bricks out of waste plastic, and particularly in third world countries, they're doing this as well. They're using plastic bottles filled with clay or dirt or dust or whatever to build. One other great thing that I didn't mention is that it's really efficient in terms of heat, in terms of containing heat. It's an insulator, it's an insulated material, so it's really good in that regard. The other side is that it sits outside regulation. Like, how are you going to regulate this? It doesn't sit in the building code at all, which is really, it's something that is almost insurmountable from a startup perspective, because for me to go to an investor and say, hey, I need $1 million to buy this machine, they say, cool, we'll make regulation. I say, no. And they say, we'll test it and make sure that it works before. And it's like, well, hold on a minute. I had to buy the machine so that I could get it through the regulation, but if I can't get the funding to buy the machine, then I can't test it against the regulation. So there are some significant challenges on this side. However, with the Curox team over in Hamilton, they met the regulation before they actually bought the machines. They looked into the costs. In 2020, so in last year, the first 3D printed house that met European building standards was completed. In 2017, the first couple or first people to live in a 3D printed housing development was in France, and they're also doing it in a lot of other countries too. So if you jump on Google and have a look at 3D printed houses, you'll see that it's starting to come online. So I know of at least 3 projects that have come online and are working now. So the technology required to meet the shortfall in housing production exists today in the form of concrete 3D printing systems. And these systems can easily be adapted to use even more sustainable and recycled materials such as waste plastic, leading to a dramatic reduction in cost and environmental impact. So I guess it sort of goes back to a little bit like what Alistair was saying before. It's like, you know, there's all this investment, there's all this infrastructure, there's all this want, and there's absolutely a need, we can't argue about that, but like, what are the actual practical applications? What are the things that we can actually do to increase production for housing? Take, for example, the whole Kiwi build fiasco. They were looking at projecting 10,000 new homes per year to meet that. We're only producing 2,500 to 3,000 with our current production capacity. You know, the numbers just were staggering when you start to look at what's needed. Especially if you start looking at kit set homes and things like that. These are great. Like, you know, you can have a production line pumping out houses, but who's going to put them together? You know, there's not enough people who are skilled enough to do that. With this particular technology, that you'll see a lot more come online. I know of at least another dozen of projects that are going to come online soon that will dramatically increase these production capacity. And some countries, specifically Dubai, have committed to 25% of all construction to be using additive manufacturing by 2025. It's 4 years from now. That's crazy. So there's some really cool things happening, and I think that it's probably going to be one of the biggest changes in the construction industry that we see in the next few years. I'm done.
Cool. Awesome. Please thank Matt. So, one of the most exciting opportunities, I think, in our ecosystem right now, we're lucky to have Matt here. Has anybody got any questions for Matt about 3D printing houses? Yes, Bobby.
Yeah. Do you have any view on use of natural materials for 3D printing?
Yeah, absolutely. So there was a project that actually sort of kicked off my interest in 3D printing as a whole. It was called a Habitat Challenge. It was run by NASA. So the idea was, how do we build, houses for astronauts who are going to live on Mars? And what they use is a biopolymer that mixes with the locally sourced Martian surface dust, and they actually printed a house. And it took 36 hours, maybe less, which is pretty crazy. So yeah, these technologies exist right now. You can buy them now if you wanted to.
Anybody else? Yes, Deb. Perfect.
Have you considered using recycled textiles as part of your product source?
It's funny you say that. There's a container around the corner that contains waste wool products. The cool thing about wool, and I don't know if I didn't know this, but wool can't melt. Like 600 degrees, I think it starts to combust in that. So if you're looking to get around those sort of heat sides of things, and you're looking to get around the types of problems with your flammability, yeah, absolutely. You can add anything. One of the products we're looking to develop, and we targeted as one of our additives, is calcium carbonate. Anyone know what calcium carbonate is? It's antacid, basically. And we can put that into the recycled plastic to make it as one much cheaper filler. It's about 30 cents a kilo if you use it. It's marble dust, so for anyone, like marble, it will come out looking like what we would call an engineered ceramic. So there's actually, I don't know if anyone's heard of the poured stone bench tops. Has anybody heard of that? And the problem that's causing with the silica in there? Yeah, well, the cool thing about this particular additive is that it's neutral to the body and it doesn't cause these types of issues. But I mean, you can put anything in it if you really want to. Especially if you're looking to change the characteristics like strength or finish or things like that.
We'll talk about it.
Any other questions for Matt? Yes, Imogen. And then at the back, go in Charlotte. Sorry, I didn't see you there. That's good.
I was going to say, like, that seems really obvious and it's not much of a financial outlay, but if that's the barrier, like, surely there's an incentive from different manufacturers or companies or even government to give this a real go, I would have thought. So
It's a good question, I need to be careful what I say here. I went back to the original investors who invested in my previous project and asked them to, would they like to invest in something like this? And I was put through the same ringer as the first time. So for me personally, I was like, I can't do this. I need someone that's 100% committed to do it. And you would expect that that would be the case. I think in terms of the industry, so I went to Classic Builders and I asked them the same question. I said, hey, you guys into this? And they are looking at their own options, particularly around PVC for building wall panels. But when you're so busy that you can't meet the current demand, do you really need to innovate? Do you need to spend $1 million buying a new machine? Probably not. So that's just my personal experience.
Kia ora. Thanks very much. Super interesting. My question is around what you would expect the lifespan of a house, perhaps 3D printed plastic would be. I'm a little bit conscious of sort of taking a problem and just postponing the end of life of that house.
It's a really interesting question. So the interesting thing about plastic is we call it single use. The particular polymer that I'm talking about is called PET. I'm not going to try and say it. Well, I will. It's polyethylene tetraphthalate. And it's the same thing Coke bottles are made out of, sushi containers are made out of. It lasts in the environment for up to 500 years, which is a problem, right? So that's a problem because when it's single use, which is an interesting thing that we call it, because we only use it once, and you can actually reprocess it 6 different times before it will lose its mechanical properties. And then, if you want to increase those mechanical properties, you just add 5% less of virgin plastic, and it'll bring those properties back to life, which is pretty incredible.
So they'll last a long time.
Yeah, which is a good and bad thing though, because if you want to tear one down and you want to make it into something else, you'll be reprocessing it. So in the consideration of when you would be building these products and building these structures, you would need to consider the full life cycle of the products. But that's more of probably it's more of a technical implementation, design implementation.
Just move it off afterwards.
Yeah.
So I think one of the really interesting things, apart from the whole thing actually, but one of the interesting thing is that the research you did, we needed to be building 100,000 houses or more.
10,000 houses per year.
10,000 houses per year. I think that's actually gone up in the latest estimates, and we're not building more than 2,000, 3,000, 4,000 houses a year. And we won't be able to because we don't have the people and we don't have the materials. So what else are we going to do? These are kind of the things that require support from our community and our public to go, actually, these things are things that we want to start looking at now, because if we don't start implementing them now, in 10 years' time, it's going to be even more of a problem that we're going to have to catch up on. So investment in people like Matt, who are actually thinking beyond what we're doing today to come up with solutions for the future we want to see, is really important. We're going to have Matt back on our panel afterwards, but will you please for now say thank you very much indeed.